so that it'll be, I can send a video out of it for it later. Okay, so let's see. Okay, so it says 47% of U.S. adults have very little confidence in newspapers. We randomly select 10 U.S. adults. Find the probability that the number of U.S. adults who have very little confidence in newspapers is, we're going to do the first part. We're going to do exactly 5. Okay, so we want to find out of the 10 adults that we're going to pick, we want to figure out what's the probability that exactly 5 of them have little confidence in newspapers. So, y'all, the way I'm going to do this, I'm going to use my calculator, okay, and we're going to use a function on our calculator, y'all, called the Binomial Pdf, right? And I know in 4.2 we had a formula, but I also did the calculator stuff because the calculator stuff really works a lot quicker, okay? When I'm doing my Binomial Pdf, y'all, we're going to have 3 parts that we're going to enter in. We're going to have our n, which is the number of people that we're looking at. We're going to have our p, which is our probability, and then we're going to have the x, which is the probability that this number is experiencing this case scenario, which we have here about the confidence in the newspapers, okay? So I'm going to do this again. I'm going to write Binomial Pdf, right? We have 10 people. The probability here is 47%, so it's a 0.47, and we're looking at exactly 5. So I'm going to put 5 right here. So y'all, I'm going to do this part on my calculator. I'm going to show you how you can get to this on your calculator. So it really doesn't matter if you're using the 83 calculator, the 84, or you're using one of the apps. It's all going to work out the same way. So on your calculator, y'all, we're going to hit the second button, and then we're going to hit the button that says VARX, okay? So let me get my calculator going here, and I'm going to stop sharing this screen with you guys so that I can share my calculator, and you guys can see this. Here we go. And okay, so my calculator's coming up. Again, it really doesn't make any difference which calculator you're using. The 83, 84, Inspire, Plus, doesn't really make any difference. Apps. Second, VARs. I'm going to go down to Binomial Pdf. So on my calculator, I got to scroll a little bit. It's a little bit different from my app, but it's right there, Binomial Pdf. I'm going to hit enter, and then I'm going to put the numbers that I had, which was 10, comma, point, I think it was 47, comma, and then the number 5, and I'm going to hit enter, and I believe the directions were telling me we're going to be rounding to like 3 decimal places. So if you notice the 3 decimal places, y'all, I would end up with 0.242. So let me stop sharing this, and let me come back to my notes. My notes right here. Yes. So I'm coming up with 0.24. Oh, I already forgot what it was. Yeah, 0.242. And let's see, 47. Was that what it was? Yes. Okay. So here's my answer, right? I'm going to stop sharing this. I'm going to share one more time my screen because I want you guys to see it as I'm entering this in. It's going to be working out nice and pretty. So here we go. 0.242. And let's check it, and whoo, we got it right. Okay, so we got part A right. Now we're going to do part B. So look at what part B says, at least 6, okay? So let me stop sharing this. I'm going to come back to my notes again one more time so we can kind of follow along. And the notes say, part B says at least 6. I want to think about what at least 6 means. At least 6 really means the same thing as 6 or more. So think about what that means. We would find the probability that exactly 6 people have little confidence in newspapers. And we would do the same thing for 7, 8, 9, and 10. And we would have to add each of those numbers up because it's 6 or more, right? So instead of me doing what we just did a little while ago, and going through that process 5 times because we got to do it for 6, for 7, for 8, for 9, for 10, I can think about the general idea. If we were to take the probability that nobody has little confidence in newspapers, or 1 person, or 2 people, and I'm going to keep playing this game, y'all. Let's see, 4, 5, 6, right? 7, and we went all the way up to 10, if we were to take each of those numbers, find the probabilities for each of them, and add them all up, we would come up with the number 1. Okay? Since we're trying to find 6 or more, this is what we're looking at. Okay? We're looking for 6, 7, 8, 9, and 10. I want you to notice that's exactly what I have right here. That's 6, 7, 8, 9, and 10. If I can find what this number is going to be, then I can find this answer by taking 1 minus whatever this is going to be. So the way I can figure out this part right here is on my calculator, we're going to use something called the Binomial Cdf. What C stands for is cumulative. Cumulative means it's like accumulating, okay? So cumulative means we're adding up all those numbers. And I'm going to do this the same exact way. I'm going to go N, P, and X. And so when I do this on my calculator, y'all, it's going to be Binomial Cdf. Our N was still 10. Our probability was still 0.47. We're going to stop at the last one. Again, remember what that means. I'm going to start from 0, and then whatever number I put here, it's going to go from 0 all the way to that number. So let me show you how I'm going to do this part on my calculator, and then I'll show you how we're going to get our answer. So I'm going to come back. I'm going to pull up my calculator for you guys. Let me see. Let me get it here going. Here we go. And, okay, notice you can see it. So, look, we're going to do the same thing. We're going to go second in bars. We're going to scroll down. That's PDF. I want the next one. I want the CDF right here. So I'm going to hit enter, and everything is going to look exactly the same. 10, comma, 0.47, comma, 5. I'm going to hit enter. There we go. Notice the number that we came up with, 0.69. If you look, y'all, at what I had right up here for this part, it looks almost the same as this one. The difference is this one has the PDF, this one has the CDF. The PDF is telling me exactly at what's the probability that exactly 5 did. The probability was like 0.24. This is telling me the probability that everybody from 0 to 5 would have. And if you look at that number, 0.69, it's more because we've added up the 0, the 1, the 2, the 3, the 4, and the 5, okay? So again, the 3 decimal places, y'all, I would go 0.694. Okay, so let me stop sharing this right here. Let me pull up my notes one more time. And so this number we came up with was 0.694. Now, remember what we're trying to find. We're trying to find from 6 to 10, right? We're trying to find from 6 to 10. So if I'm trying to find the probability from 6 all the way to 10, I'm going to take 1 minus 0.694 because this number was the 0.694. So I'm just going to do that real quick, y'all, on my calculator. I don't think you need to see me subtract 1 minus 0.694. 1 minus, I'm actually going to do my answer. And the number that I'm coming up with is 0.306. I'm going to 3 decimal places, okay? 0.306. So that's giving me that part right there. So let me share that part with you guys so you can see, again, exactly what I'm looking at. And we said the answer was 0.306. So right here, I'm going to put 0.306. And I'm going to go chickadee check, and we got it again. Okay, now let's do the third part. So look what the third part says. The third part says less than 4. Okay, so let me come back to my notes one more time so that we can see what's happening here. Okay, so now we're going to do part C, less than 4. Let's think about what less than 4 means. Less than 4 really means the probability of 0, the probability of 1, the probability of 2, plus the probability of 3. Because it has to be smaller than 4, right? So again, I want you to think about this piece right here. the way I can find this piece, y'all, is again using my Binomial Cdf, again, because remember, that means cumulative, right? I'm adding them up. My n is still 10. My probability is still 0.47. And where are we stopping at? We're stopping at 3, right? So again, I'm just going to do this piece right here, y'all, on my calculator. So I'm going to stop sharing this, pull up the calculator for you guys one more time. And let's see. Should be coming up. Here we go. Let me clear that out. So I'm going to go second bars. Again, remember, we're looking for the CDF. There we go, Binomial CDF. Let's enter that in. We got 10, comma, 0.47, comma, 3. And I'm coming up with 0.255. So to 3 decimal places, I would say 0.226, right? So let me stop sharing this. And let's come back to our answer. And let's see. Here we go, right here. And I'm coming up with 0.226. And I'm going to check it. And we got it. So before I go on, and I'll go back and I'll do 3.4, Ivy. Eric, is this making sense on how I'm able to do the second part, the third part, on that kind of stuff? Yeah, it is. Good. Excellent. Good. I really wanted to make sure that we were okay with it. Okay. So I'm glad this is working. And Ivy, I'm glad this is working for you too. So Ivy, let me go back and do the microwave problem. Again, I want to make sure that we're good here, y'all. So I'm going to come back to my assignment. And let me see. Let me pull up the microwave problem. It was 3.4. And I think it was problem number 13, and maybe it was number 12. Let me see. Pull it up right now. It's number 13. I'm going to click a similar question so we can do this together. And let's see. Here we go. And copy this. Let me put this in my notes. There we go. I think I heard something in the chat. I will double check right now what's going on. And we come back over here. Yeah. So Ivy, yes, there is kind of an expectation that there's going to be certain things that you guys are going to have to know. Now, I will tell you this. My recommendation is when you're with any of this stuff, if there's certain things that you don't know, like if you don't know enough, if you don't know a whole lot about a deck of cards, what's going to be your friend is Google. You're gonna want to do something like, hey, let me Google, what does a deck of cards look like? So I'm actually going to show you guys something real quick. Actually, before I do this problem here, let me share something with you guys. I'm glad you all are here because I think this is going to come in real helpful. And I know it's different, you guys, because we're not together, we're not in person or whatever, but I'm glad that those of you who are here are here. So what I would do is I would just look, you can see I'm Googling, right? And I'm going to type in deck of cards. And I'm going to go to images so I can get a better look. And let me see. I'm going to see if I can pull up this one here. And let me see if this is going to let me do this. If I click on this. And I don't know if I'm still showing the same. Yeah, okay. Let me share that screen with you guys because that one went away. And here we go. I think this is it. Yeah, here we go. And then what you can do is something like that. There we go. And now you have an idea of what a deck of cards looks like. Yes, it's whoever's writing these books, y'all, they're gonna have to start making some changes because, like, I'm 48, guys. When I was a kid, I grew up playing cards with my tios and my tias and that kind of stuff. And there was always a deck of cards. We had 4 or 5 decks of cards at the house. I played with my brother when we were little kids, that kind of thing. I played with friends, you know what I mean? Cousins, all that kind of stuff. And I've noticed over the years, the experience that I had playing like with an actual deck of cards, not everybody has had that experience. So some people, their experience with cards was like on the family computer playing solitaire or King's Corner, that kind of stuff. And then like the newer generation, they don't necessarily have an experience with cards. So yeah, anytime you're coming up with something like that, you're definitely going to want to use Google so you can like, look at the pictures, right? That kind of thing. That's going to be really helpful. So I'm glad you asked that because I want to make sure that you guys are okay with some of these things. And hey, you know what? If it's something you're not familiar with, sometimes there's a question about rolling a die, and you may not have an experience with rolling a die. And so just Google it. What does a die look like? This kind of thing, so that you get an idea. Again, some of these problems, the way they were written, it was kind of like almost everybody knew what these things were 20, 30 years ago, but that's not necessarily the case now, okay? So anyway, I'm glad you asked about that. Let me get back to the microwave problem so that we can figure this thing out. And I really want to make sure that you guys are good with the microwave problem. I know it's kind of a tricky problem, but I think once we get the hang of it, it becomes pretty easy to understand. Okay, let's take a look. So we have 12 microwave ovens. 4 of them are defective. So the first thing I'm going to do is I'm going to do this. We have a total of 12 microwaves. 4 of them are defective. That means that 8 of them are not defective, right? Okay, and it says the restaurant is going to buy 3 of them. It says, what's the probability of the restaurant buying at least 2 non-defective units? So we want at least 2 coming from here. Okay, so let's think about it this way. We have a total of 12, and we're going to buy 3. So, y'all, the first thing I'm going to do when I'm doing my problem, I'm actually going to write out my denominator. So my denominator is going to be 12, and we're going to choose 3 of them. Okay. Now, remember how many we're buying, right? We are buying 3, and we want at least 2 of them to be not defective. What does at least 2 mean? It means that either 2 are not defective, and then 1 of them is defective, or 3 of them are not defective, and 0 would be defective. We're only buying 3, right? So these are the 2 case scenarios that we're going to have. Okay. So let's do it like this. Let's do this first part. Suppose we get 2 non-defective and 1 defective. How would we do that? Well, from the 8 that are not defective, we're going to choose 2 of those. And then from the 4 that are defective, we're going to pick 1. Okay. Or we could say from the 8 that are not defective, we want all 3 of them to come from there. And then from the 4 that are defective, we're not going to choose any. In terms of how I'm writing this out on my paper, is this part making any sense, y'all? How I'm writing this out? Christine, I'm glad you're here, Christine. Good. Okay, excellent. Ivy, I'm glad we're good with how I'm writing this out, okay? So again, I'm going to go, since Christine just joined us, y'all, I want to just explain this concept again because I don't want her to miss it. I think this is a good problem, and I really want to make sure that we're good here, okay? So, Christine, we're doing the problem again with the microwave ovens, right? So just to recap, there's a total of 12. 4 of them are defective. So here's my 12. 4 defective, that means 8 of them are not. And we're going to buy a total of 3. So that's why I wrote over here, we're buying 3. And it says, what's the probability of buying at least 2 non-defectives, right? So what does at least 2 mean that are not defective? It means 2 would not be defective and 1 of them would be, or 3 are not defective and we don't pick any from the defective group. So the way I did my numerator is I said, look, if we're going to look at, say, this case scenario here, we're going to pick 2 non-defective and 1 that is defective. So out of the 8 that are non-defective, we're going to pick 2 of them. And that's how I got this piece right here. And then from the 4 that are defective, we're going to pick 1 of them. That's how I got that piece. The other case scenario we could say is, look, we're going to get all three being non-defective. So from the 8 that are not defective, we're going to pick 3 of them. That's how I got that number. And then from the 4 that are defective, we're not going to pick any. That's how I got this number. My denominator was from the total of 12, we were buying 3. So that's how I wrote this part out. Now, I know it got a little messy here, y'all. I'm going to show you when I'm going to enter this in on my calculator, the way I would do it with parentheses would be like this. I would go 8 choose 2 times 4 choose 1 plus 8 choose 3 times 4 choose 0. And this is kind of how I would enter. Actually, I would probably do it like this, with another set of parentheses here and another set of parentheses there. So this right here, y'all, is how I'm going to enter my answer in on my calculator. So let me show you guys how I'm going to do this, okay? So let me stop sharing this, and let me pull up the calculator again so you guys can see this. Boom, boom. Here we go. Okay, turn it on. So remember, I had 2 sets of parentheses, one from the very beginning, and then I said we were going to do 8. Where's my math button? Math, choose. We're going to go down here. 2 times 4, math, probability, choose 1, close that off, plus 8, math, probability, choose 3 times 4, math, probability, choose 0, close that off again, and then divided by, we had 12, math, probability, let's see, choose, and again, we're buying a total of 3 of them, right? Okay, so let me enter this in. Whoa, something isn't coming out right. Okay, hold on, guys. I made a mistake somewhere. Let me see. Let me start again. Parentheses. What do we have? Make sure we're doing this right. 8 choose 2, 4 choose 1. Let me see. Oh, here we go. 8 math, probability, choose 2 times 4 math, probability, choose 1 plus, maybe I hit a times or something. I don't know. It's supposed to be a plus. 8 math, probability, choose 3 times 4 math, probability, choose 0, divided by 12 math, probability, choose 6. Okay, there we go. Oh my God, we're still making a mistake. Go choose. I think I forgot an extra parenthesis maybe at the top. Here, let me insert that extra parenthesis right there a second. Insert parenthesis. There we go. Okay, now that should work. There we go. So look at the number I'm coming up with. I'm coming up with a 0.7636. And I want to say the directions on this column point around the 3 decimal places. So y'all, I would enter this in as 0.764. So again, let me stop sharing that. Let me come back here. Let me share my screen. Where are we? Right here. And here it is. So right here, I'm going to write 0.764. And I'm going to go chickadee check. And we got it. Okay. So that's really how I'm doing a lot of these problems, you know. And you can see, guys, even as I'm doing it myself, you know, I got to be real careful, make sure I'm putting all my parentheses in. It takes time to do, there's no doubt about it. But you really want to go slow with it, okay? So just take your time, you know. And if you think about it this way, y'all, probability should always be given to me as like a decimal. It's never going to be a number more than 1. So the first time I entered my numbers in, and I got like a number of like 112. I was like, okay, I did something wrong here. My answer should always be like point something or 1/2 or 1/3 or 7/11, something like that, but I shouldn't be getting a number bigger than 1. So that's how I knew the first one, something wasn't right there, okay? Let's see. Let me get out of here. Well, actually, I'll leave this here for right now. But are there any other questions that you guys want to ask me about anything? We did 4.2 number 5. We did the microwave problem from 3.4. Are there any other questions that you guys want to ask me? Christine, Eric, Evelyn, Ivy, anything? You can turn on your mic or you can put it in the chat, whatever works best for you guys. Anything? Everybody's so quiet.
Could you do one of the problems from 4.2?
Yeah, okay, so we did number 5. Which one do you want me to do? Because you did do number 5 already. Yeah, but I can definitely do any of the other ones. I'll tell you what, let me do it like this. Let me come back here and go like this. Let me pull up another one from 4.2. So let me pull up, I don't know, I'm going to pull up like question 6.
Okay.
Okay, and I think I heard something also in the chat also, so let me double check. Yes, and Ivy, I'll definitely do something from 4.3 as well. So look, this is actually like the one that, maybe I might have 2 Christines, because Christine, I think you were asking right now, and then I think there was somebody, another girl had asked me about this particular problem yesterday. But I'll tell you what, let's do them both. I want to make sure again, guys, that we're good with these here. So let me do this one, and then Ivy, I will definitely pull up something from 4.3. Okay. So let me get to my notes here, and I will paste this problem in here, and let me share my screen with you guys. You can see what it is I'm looking at. Here we go. Okay, so let's go through this problem here, y'all. This is just like number 5 from 4.2, but it says 36% of adults say cashews are their favorite kind of nut. You randomly select 12 adults and ask each to name his or her favorite. Find the probability that the number who say cashews are their favorite nut is, we got 3 parts. Let's do the first part, exactly 3. Okay, so y'all remember, I'm going to do this using my Binomial Pdf. What the Binomial Pdf stands for is we're finding the probability that a particular number of people out of the total prefer whatever is going on here. And in this case, they're saying cashews are my favorite. Okay, so look, we're going to do it like this. We're going to go Binomial Pdf. My n refers to the number of people that we're selecting. We're selecting 12. P is the probability. The probability in our case, 36% as the decimal, y'all, is 0.36. And we're looking for exactly 3 out of those 12. So again, this is how I'm going to enter this in on my calculator, okay? So let me show you on my calculator how I'm going to do this. I'm going to stop sharing this screen here, and I'm going to pull up my calculator for you guys so y'all can see exactly what it is I'm looking at. And okay, let me turn this thing on. Let me clear my screen. So on my calculator, y'all remember, I'm going to go second and then bars, and I'm going to scroll down until I hit the Binomial Pdf. That one right there. Notice there's 2. There's the P and there's the C. Right now I'm using the P. Okay. And we said we had a total of 12 folks. 37% of them like cashews, comma, and we're looking for exactly 3. Guys, notice between each of my numbers, I got to put a comma. So 12, comma, 0.37, comma. Okay, Evelyn, I'll get to yours right in 1 second. Let me close this up here. And so the number I'm coming up with is 0.174. So let me see. Evelyn, can you do me a favor? Are you using the calculator or using the calculator app? You know which one you're using? Are you using an app, oops, or using an actual calculator? Okay, so do me a favor. Is it this one? Okay, let me see. I'll tell you what. Look, I haven't used that one there. Look for this app or this app. I'm not saying that the one that you're using doesn't work. It might be there, Evelyn. You just might have to scroll a little bit more. Like you might have to go down a little bit more. You might use the down arrow. But these two here, Calculate 84 and Graph and Calc 83, just to let you know, this one here is free on the Android. It used to be free on Apple products as well. This one here is free on Apple products, okay? And I'll come back to you in 1 second, okay? So let me come back to our problem, guys. So look at the number we came up with, 0.174. I'm going to come back to my original problem right here. And I think it's coming up for us. Here we go. So let's put 0.174. And, oh no, what happened? Did I do something wrong? You know what? It's 36, and I think I put 37. That's what it was. I think on my calculator, I may have put 30. Yeah, I put 37, guys. That was my bad. Let me share my calculator, guys, so you can see what I did wrong. And let's see. Oh, this is my bad. Here it is. And the number was 36, and I put a 37. Easy way to fix it, go second and enter. And it types in exactly what you had, and then you can just come back over here, change that 6 to a 7, come down. There we go. So 0.185. That should be my answer. Jimmy Omar making mistakes, putting in the wrong numbers. 185. Boom, we got it. Okay, there we go. No biggie, no biggie. Okay, now let's do part B. So part B says at least 4. Okay, so let me get out of this part so I can show you again on my notes how I'm going to do the second part of it, which says at least 4. Okay, when we do part B and it says at least 4, what pops up, y'all, is this. And I want us to understand what at least 4 means. At least 4 means 4 or more, okay? Think of how many people that they selected here. They selected 12. So if we want 4 or more, what that really means is that we're going to look for 4, for 5 people, for 6 people, for 7, all the way up to 12. That's really what I'm trying to do here. But, and I could do this, y'all. I could do this exactly like the way I did that one, and I would just change this number to 4, and then whatever number I would get, I would write it down. And then I would change it to 5, and whatever number I get, I'd write it down. And I would have to keep doing that, and I'd add them all up until I got to 12. But instead of me doing that, I want you to think about something. If we were to take the probability that nobody likes cashews, and the probability that one person likes cashews, and 2 people, and 3 people, and 4 people, and 5 people, and we were to keep playing this game all the way up until we got to 12 people, if we took all those probabilities and added them all up, we would end up with the number 1. Okay? Now I want you to think about what it is I'm trying to find. We're trying to find the probability from 4 all the way to 12. This is the part that I'm trying to find right now. Okay? From 4 all the way to 12. If I can find this piece right here, then whatever number I get here, I'm going to make this up. I'm going to say this number is X. Okay? I'm just using that because I teach math and that's what we use, right? So suppose that number there is X. If I wanted to find this piece here in the red, I would just say, let's take 1 minus X, and we would get our answer. Now, there's a way that we can find this part. The way we find that part, y'all, is we use something called the Binomial Cdf. It still has these same pieces here. The letter C here, y'all, stands for cumulative. Cumulative means I'm adding them all up, okay? So I want you to think about the parts that I'm going to find. I'm going to try to find this part. And the way I do that on my calculator is, let me see, my n was still the number 12. Our probability was 0.36. I don't want to make that mistake again, 0.36. And then this number here is telling me where we're going to stop. So we're going to stop at 3. We're going to go from 0 all the way to 3. Okay. So again, I'm going to show you how to do this part on your calculator. So let me stop sharing this. Let me pull up my calculator here. And here we go. Okay. So guys, I'm going to come back here. I'm going to go second. I'm going to go vars. I'm going to scroll all the way down here. That's the one I'm looking for, the CDF. Okay. Let's hit enter. I'm going to go 12, comma, 0.36, comma, 3. Now I'm going to hit enter here. And look at the number I'm coming up with. It's 0.320. Guys, if you look at what I have right here, and you look at what I have right here, the difference is this is the P and this is the C. This is telling me, this part here is telling me what's the probability that exactly 3 people like cashews. This one here is telling me what's the probability that nobody likes cashews, or 1 person likes cashews, or 2 people like cashews, or 3 people like cashews. So it's taking each of those numbers and it's already adding them up for me, okay? So that number is 0.320. Let me come back to my notes because I want to show you what it is we're going to do. We found that, let me get my eraser. We found that this number right here, y'all, was 0.320, because the number after that was a 1. And remember how we said we were going to find this piece in the red? We were going to take 1 minus 0.320. So I'm going to do that on my calculator. I don't think y'all need to see me subtract 1 minus 0.320. And the number I'm coming up with is a 0.68. So I'm coming up with a 0.68. Okay. Let me stop sharing this part. Let me come back over here to my problem. And right here, I'm going to type in 0.68. I'm going to check it. We got it. Okay. And then let's do part C, and then we'll be done. Okay. And I want you to notice something, y'all. Look at how they're writing part C. See right there, it says probability of X is less than or equal to 2. I want you to understand that because when I come back to my notes, right, and I'm going to answer part C, right here where it says, excuse me, at most 2. I want to think about what does at most 2 mean? It means 2 or less, right? At most 2 means I don't want more than 2, so 2 or less. That would mean I would take the probability of nobody likes cashews, or 1 person likes cashews, or 2 people like cashews. Because we're adding all of those up, y'all, again, I'm going to go with binomial Cdf, okay, with my n, my p, and my x. Okay? And so this is still going to be binomial Cdf. My n was still 12. Our probability was still 0.36. And where are we stopping at? We're stopping at 2. Okay. Evelyn, if you're still here, were you able to find the Binomial PDF, CDF on either one of those apps there? On either the Calculate 84 or Graphing Calc 83? And it should be in the same spot like the way I'm doing mine on my calculator. So let me pull this back up for you guys one more time. Okay, so again, I'm going to go second, vars, scroll down all the way till I hit, let's see. Okay, good. I'm glad it's working, Evelyn. And Christine, I'll get to you right now. Let me see. So we have 12, comma, 0.36, comma, 2. And let's go enter. And so the number I'm coming up with y'all here is a 0.135. So let me stop sharing this. Let me come back to my problem right here. And we said we're going to enter in 0.135, and let's check it. And we got the problems, okay? So let me see. I know, Christine, you were putting something in the chat. Let me just double check. Can I see? I cannot see how many times that you, Ivy, this one here was CDF again. It was CDF. For any time you're adding a bunch of numbers together, it's always going to be CDF. If you're finding it for a particular value, then it'll be PDF. Christine, I'm not able to see how many times you do a problem. It doesn't show me that. But what I'm hoping is that now that we've gone over this, that this is making more sense, okay? Is it making more sense? Are we good? I'm doing at most 2 and I got the same number as 4. I don't know what you mean. Doing at most 2 and I got the same number as 4. Can you?
I have the Binomial Pdf, but my numbers are 12.31 and at most 2. So I typed it on my app, and it gives me the same as the at most 4.
Okay, so I'll tell you what. Let me hold on real quick. Let me do this. Are you doing part A, B, or C?
C.
C. Okay. So look, let me stop sharing this real quick, and let me pull up my notes. Okay, so you had a similar problem, right?
Mm-hmm.
But let's see. Let's come back over here, and this is what we're going to do. We're going to do your part C. Okay, so in your part C, what percent did you have?
31.
31. So 0.31. Okay. Is it still 12 people?
Yes.
Okay. And then your part C was still at most 2?
Yes.
Okay. At most 2 number means x is smaller than or equal to 2, right?
Yes.
So if I'm doing your problem, Ivy, the way I would do yours, I would go binomial CDF, right? Where my n is 12, this is 31, and this is 2.
Okay.
Is that better?
Yes.
Okay, perfect. Good. Excellent, good. I'm glad it's working out.
I think I just didn't press enter. I'm a little stressed.
Okay, no, you're good. You're good.
Okay. Thank you.
Let's see. Oh, and then Ivy, you wanted me to do something out of 4.3, right? So let's pull something here, guys, out of 4.3, and we will take a look, see at what it is we got. Okay, I'm gonna leave this. Okay. Okay. So I'm gonna pull up. Let me see if I can get this real quick. Get rid of that. Get rid of that. Put this up here. And let me see. Okay, that. Through. Okay. Here we go. Okay, so guys, let me share with you guys something real quick, so we can do a problem or two out of 4.3. Okay, so let me get this here, and I'm going to do again a little copy and paste, and I'm pulling up my first problem here, y'all, out of 4.3. Okay, so let me see. Let me get my notes if I can find them. Here we go. Okay. So let me stop sharing that, and I'm going to share with you guys my notes from, or my problem, sorry, from 4.3, okay? All right. So this is my question number 1, and what I'm trying to do here, y'all, is I'm going to pull something up real quick, too. Give me 1 quick second. See that? I'm going to paste this in my notes too. Okay, so I think you guys can still see everything. Yep. Where did we go? That's not what I'm looking for. That's not what I'm looking for. Okay, so here's my first problem. It says basketball player Chauncey Billups of the Detroit Pistons makes free throw shots 88% of the time. Find the probability that he misses the first shot and makes it on the second. Okay, guys, all I did here is I just did a little copy and paste from my notes. This is what we call a geometric distribution. The way I know something is geometric is we're going to keep trying this until we succeed. It says repeated trials are independent of each other. The probability of success P is the same for each trial. And then there is a formula right here, okay? So the formula says P of X is equal to little p times Q to the power X minus 1, where Q is 1 minus P. And I'm going to explain all that kind of business to you guys, okay? So here's my first example. And I want you to notice that this problem right here, y'all, is real similar to this one here, okay? So the way I'm going to do this piece is I'm going to use this formula right here, which is P of X is equal to P times Q to the power X minus 1. P is the probability that we're gonna succeed doing whatever it is we're doing. So if you notice here, y'all, this basketball player makes free throws 88% of the time. So the probability that he makes it is 88 or 0.88. The probability that he misses it is going to be 1 minus 0.88. That's going to be the same thing as 0.12. All I'm going to do here, y'all, is fill in the blanks, okay? So look, I'm going to come back over here and I'm going to say P of X is equal to 0.88. I'm going to put that in parentheses just because I'm going to be multiplying stuff, times 0.12 to the power X minus 1, okay? Now, I want you to notice, I'm going to try not to zoom out too much, but it says find the probability that he misses the first one, but when does he make it? He makes it on the second. So if he makes it on the second shot, that's really all I'm concerned about. That's telling me that my variable X is going to be the number 2. So right here, I'm going to write 0.88 times 0.12 to the power 2 minus 1. So this is 0.88 times 0.12 to the power 1. This is the same thing as 0.88 times 0.12. So again, I'm just going to take my calculator. I don't think y'all need to see me do this on the calculator because I'm just multiplying, right? 0.88 times 0.12 equals, and I'm coming up with 0.1056. That's the number that I'm coming up with. So when I come back to my problem, I'm going to say, oh, look, there it is. There's that 0.0156, right? So now that I've done the first one, I want you to look at the example that I have here, because this problem is exactly like the way it was, is it kind of very much like the way the first problem that we did was, okay? Let's do the same thing. Look, what's my little p? He makes his free throw shots, 0.80. Remember how I'm going to do Q. It's going to be 1 minus 0.80, which is 0.20. Okay? So when I write out my formula, y'all, it's going to look like this. 0.80 times 0.20 X minus 1. Now, it says find the probability that Tony makes his first free throw shot on his third or fourth attempt. We're going to do it in pieces. We're going to say, suppose he makes it on the third attempt. 0.80 times 0.20, 3 minus 1 is 0.80 times 0.20, 3 minus 1 is 2. Let me show you how I'm going to do this part on my calculator, okay? So I'm going to enter this piece in, y'all, on my calculator exactly as I see it. Let me pull that up for you guys. You can see what it is I'm doing.
Did you get the 20 because it has to equal 100?
Yes, ma'am. And
Okay.
so, yes, and so what I'm doing, the way I'm coming up with that 20, I'm doing 1 minus whatever my 0.80 is. Yeah. So let me go ahead and enter this part into my calculator. So remember what we had? We had, let me see. Here we go. We had a 0.80 times 0.20. Wasn't it being squared? Like that? So notice, guys, I'm entering this in exactly like I have it here. I'm going to hit enter. I'm coming up with 0.032. So let me write this number down. So I'm going to stop sharing my calculator real quick. Let's see. And I'm going to come back to my notes right here. And the number we came up with is 0.032. Yeah, so here's my 0.20. Remember how I got it? It has to add up to 100. So I did 1 minus 0.80. Okay, that's what's going to happen if it's on his third attempt. What happens if it was on his fourth attempt? I would do it exactly the same way. Okay, so on the third attempt, this is now what I'm going to enter in on my calculator. Okay, so let me stop sharing this part with you all here, and let me pull up my calculator again right here. And I think you guys can see it. So guys, just to make it easy, I can go second entry, and it types in the same thing. And I'm just going to change that to now to a 3. Oops, oh, it didn't do it. To a 3, there we go, to the third power. Hit enter, and I'm coming up with a 0.0064. So let me stop sharing that, and I'll come back to my notes. And we got a 0.0064. You guys can see that? Yes. Okay, and now, since we're asking for his third or fourth attempt, what we're going to do, we're just going to add those numbers together. So on my calculator, I'm just doing this real quick on my calculator, y'all, 0.032 plus 0.0064, oops, another O. And I'm coming up with 0.0384 as my final answer. So let me show you another problem from 4.2. And so let me see, let me get out of here. Let me come back over here. Oh, and let's see, we can find a problem. Okay. What I like about 4.3, you guys, I'm going to pull up another problem here just again so y'all can see exactly what it is I'm looking at. Is 4.3 is pretty explicit in that it tells you what it is we're trying to find, okay, or how we're going to do the problem. So here is another question that I just pulled up directly from the homework from 4.3, and it says a staff professor finds that when he schedules an office hour at the 10:30 a.m. slot, an average of 3 students arrive. It's real specific. Look, use the Poisson distribution to find the probability that in a randomly selected office hour in the 10:30 a.m. slot, exactly 1 student is going to arrive. Okay, so I'm going to show you, I'm going to pull something up again here for you guys so you can see what it is I'm looking at. And let me see if I can find this. Where are we? Where are we? Where are we? Here we go. And I put this also in the notes, but I'm going to see if I can do something here, y'all. And so give me 1 second. I'm trying to paste something in the notes for us here. So let me do that. There we go. And I'm going to paste one more thing for us. Okay. And so let me get this on here too. Okay, so I think we can see this here. So it says, a stats professor finds that when he schedules an office hour at the 10:30 a.m. slot, an average of 3 students arrive. Use the Poisson distribution to find the probability that in a randomly selected office hour in the 10:30 a.m. slot, exactly 1 student arrives. Okay, so let me explain a little bit about the Poisson distribution. So it says this experiment consists of counting the number of times X an event's going to occur in a given interval. Usually that interval is like an interval of time, something like that, okay? The probability of the event is the same, of the event occurring is the same for each interval. The number of occurrences in one interval is independent of the number of occurrences in other intervals. And then they do give me a formula here, okay? But instead of me using the formula, I'm going to use my calculator because it's going to be that much easier. If you look at the problem that I have here, and then if you look at this particular problem that I have here in my notes, and again, I just copied this directly from my notes. Look what it says. The mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month 4 accidents will occur at this intersection? So we're looking for the probability that exactly 4 is going to happen. Look what I'm using here, y'all. I'm using something called the Poisson Pdf. Okay, so the way I would do this one is I would say, look, I'm going to use a Poisson Pdf. This mu is my average. The average here is 3. This x is how many accidents we're looking at happening. The number of accidents we're looking at here is 4. So again, on my calculator, I'm going to show you one more time how to do this in the calculator, and then we'll go back and we'll do the problem directly from the homework, okay? So let me stop sharing this business. Let me come back over here, and let me get my calculator. Here we go. Let me turn it on for you all. Okay. So I'm just going to clear my screen. Guys, the way I'm going to get to my Poisson Pdf, same way we got to the binomial. Second, bars, scroll, 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 scroll. There it is, Poisson Pdf. Right? We said the number of average of accidents was 3, and we're looking at what happens when we have exactly 4 accidents. Now I'm going to hit enter, and the number that I'm coming up with for that example in the notes is 0.168, right? So back here, y'all, what I would do right here is I would say this number here is 0.168. Now I want to see if I can apply this same principle to this problem, okay? So we're still talking about the average number of students. The average number of students is 3, so my mu is equal to 3. And we're looking for exactly 1 student. So I'm going to say, look, this is going to be my Poisson Pdf with my mu and my x. So I'm going to say this is going to be Poisson Pdf. My average was 3, and we're looking for exactly 1. Okay. So let me do that on my calculator again. And let's see, window, here we go. So it should be coming up now. Okay, I'm going to go second bars. Let's scroll all the way back down until we find the Poisson Pdf. We said that our average was 3, and we're looking for the probability that exactly 1 student shows up. And I'm going to hit enter, and I'm coming up with 1.4936, okay, 0.14936. So let me stop sharing this, come back to my notes, and 0.14936. So if I had 0.14936, and they're going to 4 decimal places, that 3, I'm sorry, is going to become a 4. And so there's my answer, okay? So guys, in the notes, I try to show you like how you can do the problem. And the same thing with the video, right? So you watch the video, it's me kind of showing you guys how to go through some of that stuff, okay? But that is a little bit of 4-3 as well. So we did 2 problems out of 4-3 already. Okay, so guys, remember, everything is due from chapter 3 and 4. It's due by tonight. Remember, it was originally going to be due on Tuesday, but I did give you guys a couple extra days to get it done. So make sure that you do try to finish this stuff up by tonight, y'all, so that you can get everything done. And then I've already uploaded the assignments and the videos and the notes for this coming week. It's 5-1 and 5-2, and then the next week will be 5-3 and 5-4. So right now, once you finish this, the idea is to make sure you start working on 5-1 and 5-2, okay? So, guys, that's our hour today. I hope this is coming in helpful. And again, just try to go through the problems, see what you can kind of figure out how to do it. But it's the problems, guys. Are if it's 4.2, it's going to be using binomial, either PDF or CDF. You'll know it's going to be CDF, which is the cumulative, if you're having to add up a bunch of numbers. If it says at most this or at least that, you're going to have to be adding some numbers up together. If it tells you it's what's the probability that exactly one person likes it, or exactly 9 people like this, or exactly 7 people have low confidence in whatever, then you'll be using the binomial PDF because it's for that particular value. Okay. So I hope that was helpful. I don't know if it was. I mean, you guys tell me if you all found it helpful. I hope you did. I hope this made some sense as we went through some of this stuff here. So let me see. So let me take a look through here. Ivy, you asking about? Okay, let's do number 7 on 4.2. So guys, I'm pulling up my number 7. Oops, and then we'll call it a day after we do this one here. So let's do this one so we make sure that we're good with it. Okay. And I want to see if you guys can still see this. No, you can. Yes, you can. Okay. So let's take a look here. It says, test consists of 10 true or false questions. To pass the test, student must answer at least 8. Okay. This right here, y'all, that's the key. At least 8. If a student guesses on each question, what's the probability that the student will pass the test? Okay, so let's think about it this way. Remember, we're looking for a couple of things. We need to know our n, we need to know our p, and we need to know the particular value, right? So n is 10 because there's 10 questions. Those questions, y'all, are true or false. If you guess correctly, what's the probability? If you guess on each question, what's the probability you're going to get it right? 0.5. Why 0.5? Because it's true or false. You either get it right or you get it wrong. If it was true and you guessed correctly, good, you got it. If it was false, but you put true, you didn't get it, right? So it's going to be 0.5. Now think about what we got to do. We got to get at least 8 questions correctly, right? What does at least 8 mean? It means 8 or more, right? So what does that mean? That means that we need to get all 8 right, or we need to get 9 right, or we need to get 10 right, right? And we would add each of those numbers up. So remember how I can do this. I want you to think about the general idea. If I have probability of 0 plus the probability of 1 plus the probability of 2 all the way to 10, that number is going to be equal to 1, right? So what I want to do is, because I'm looking for the probability from 8 to 10, this is the number that I'm looking for. So I'm going to say, look, if I can find what this number is, then once I find this number, I can subtract it from 1, and I'll be left with this part right here, right? So how would I find this part right here? Remember, I'm going to end at 7, right? I would say, look, I'm going to end that at 7. I can use my binomial CDF, where my n is 10, my probability is 0.5, my number here is 7. And again, y'all, I'll show you on my calculator how I'm going to do this piece. So let's come back here. Let me get my calculator going so you can see exactly how I'm going to do this. Okay, turn it on. Let's go second bars. Scroll down to binomial CDF. And right there, we have 10, comma, 0.5, comma, 7. Okay. Hit enter, and I'm coming up with 0.945. Okay, 0.945. So let me stop sharing this. Come back to my notes. So this number here is 0.945. Okay. Now remember, we said we're going to do. We are going to take 1 minus 0.945. So I'm just going to do that on my calculator real quick. 1 minus 0.945. And I'm coming up with 0.055. And I'm going to say, hey, look. Boom. There is my answer right there. Okay? And we got, I heard something in the chat. Let me double check. What's up? Let's see. Can I please do 1, 10, 11, or 12? Same section, Evelyn? Same section? Yeah, okay. Let's do one of those from 10, 11, or 12. And come back over here. Oh, it's got to be from something else because there's no 10, 11, 12, 4, 2. Are you asking me 4, 2 or 4, 3? 4, 3. Okay, let's go to 4, 3. Let's come back over here. 2, 4, 3. Let's take a look at numero 10. Okay. Let's see. I'm going to do a little copy and paste here, y'all, and we'll do number 10. Okay. So I'm going to go like this. Let me copy it. And let me paste it in the notes. There we go. Okay. So the question here says, find the indicated probabilities using either the geometric, the Poisson, or the binomial. Determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probabilities. Okay, let's see. Assume that the probability you make on a given sale in any given telephone call is 0.17. Find the probability that you make your first sale on the 5th call. Okay, so guys, I want you to think about what they just told me this part here. Find the probability you're going to make our first sale on the 5th call. Think about the problem that we did a little while ago with Tony Parker. We're going to make our first on the 3rd or 4th attempt. So I'm going to make my first sale on the 5th call. This is going to be that geometric distribution, okay? So I'm going to copy down the formula that I have right here. Okay, I'm just going to write that down for my problem. We come back to my problem. Here we go. So the problem is P of x equals P times Q to the power x minus 1. Okay, now let's see if we can figure out how to do this problem here. Okay, so for part A, I know that my P, y'all, is the 0.17. So I need to find Q. Q is going to be 1 minus 0.17. So I'm going to take my calculator, 1 minus 0.17, and that's 0.83. Okay. There's my Q number. So here's my general formula, 0.17 times 0.83 to the power x minus 1. We're going to make our sale on our 5th call. Okay. And so again, I'm going to do this here. 5 minus 1 is 4. This right here, y'all, is exactly what I'm going to enter in on my calculator, okay? So let me stop sharing that. Let me come back here and get my calculator for you guys so you can see exactly what it is I'm looking at. And let's see, okay, so I have parentheses 0.17 times parentheses what was it, 83 to the power of 4. Hit enter, and I'm coming up with 0.08067. Okay, so let me stop sharing this. Come back to my notes. 0.08067. And I'm going to see, what are they asking me to go to? They're asking me to go to 3 decimal places. So the 3 decimal places, I would write 0.081. Okay. So look, let me show you something real quick so y'all can see that I'm telling you all the truth. Right there, 0.081. Let's check it. We got the first part right, so we know we're good so far. Okay, part B says, that we make our sale on the first, second, or third call. Okay, so I'm going to do it like this. I'm going to stop sharing this, and I'm going to share my notes again, and we're going to make our sale on the first, second, or third call. First, second, or third call. All I'm going to do, y'all, is find each of those numbers and add them up. Okay. So remember, this is my basic formula right here. Okay. So look what I'm going to do for number 1. I'm going to put 0.17 times 0.83, 1 minus 1. 0.17 times 0.83, 2 minus 1. And 0.17 times 0.83, 3 minus 1. Okay. And I heard something in the chat. Let me see. What did I get the 5 minus 1? Because what did it tell me to do? When I look at part A, it said the 5th call. And what does my formula have? The power of x minus 1. So that's why it's 5 minus 1, which is 4. Okay, so guys, now let's go ahead and with this one here, let's see, I heard something else in the chat. Oh no, let's go back over here. Okay, you're welcome. No problem, Evelyn. Okay, so guys, first thing I'm going to do here, 0.17 times 0.83, that's the power 0. 0.17, 0.83, that's the power 1. 0.17, 0.83, and that's the power 2. Okay. So remember what we're going to do with each of these numbers, y'all. Once we get those numbers, we're going to add them up because it's an OR problem. So what's the probability to make it on a first or a second or a third? Okay. So again, I want to show you exactly how I'm going to do this on my calculator, y'all. I'm going to enter this in with pluses in the middle. Okay. So let me show you on my calculator how I'll do this part. Come back over here. Let me share my calculator with you guys so you can see exactly what I'm looking at. Okay, so I'm going to do it exactly like I have. I'm going to go second entry. Remember the first power we had was 0, right? Okay. And then I'm going to put plus second entry again. Oh, no, that's not what I wanted to do. Okay, never mind. So let me do it like this. We'll start out from the beginning. 0.17 times 0.83 to the power 0. Okay, equals 0.17 plus, I'm going to do this again, 0.17 times 0.83 to the power of 1, that, plus 0.17 times 0.83 to the power of 2 squared, and I'm coming up with 428,213. So 0.428213. I think it's still asking me to go to 3 decimal places. So guys, if I was going to go to 3 decimal places, I'd probably put 0.428. So let me stop sharing this screen. Let me come back to my homework problem. So you can see right here, yeah, 3 decimal places. And the number we came up with was 0.428. And I'll check it. Boom, and we got it. And then look what this part says. We do not make a sale on the first 3 calls. Okay, so let me stop sharing this real quick. And I'm going to come back to my notes. Oops, that's not my notes. These are my notes. Okay, so the answer that we came up with for part B, y'all, was 0.428. And that was the probability that we made it on our first, our second, or our third call. Now, part C says, what's the probability that we do not make a sale on the first 3 calls. Okay, so if we know that the probability that we do make a sale on the first 3 calls is 0.428, then the probability that we're not going to do that, y'all, would be 1 minus 0.428. I want you to think about this, and guys, I don't remember if I said this on the video or not. I made the videos, last fall when we were in the middle of all this pandemic business. But I know that when I'm in class, I talk about this. So I'm going to kind of just do a little sidetrack here. If you watch the news tonight, if you watch Tim Smith and he says, hey, there's a 30% chance that it's going to rain, then we could say there's a 70% chance that we're going to get no rain. You say, well, how do I do that? Well, I think of 30% as 0.3. And then the probability that there's no rain, I would say 1 minus 0.3 is 0.70. And 0.70 is the same thing as 70%. So if I know that the probability of me making a sale on those first 3 calls is 0.428, then the probability I'm not is going to be 1 minus whatever that is. So if I take my calculator and I just do 1 minus 0.428, the number I'm coming up with is 0.572. And if I stop sharing this, y'all, and I come back to my screen, here, right there, and right here, I would enter in 0.572, and I would check it, and we would get it right there, okay? All right, so anywho, that was number 10. I hope that's helpful, y'all. Again, remember, the stuff is due by tonight. Make sure that you do finish everything up, y'all, and good luck with everything, guys. One thing I would recommend, I know some of you said, like, I'm still working on 4.3 or whatever. Don't wait too long, guys, because then all of a sudden, you're kind of cramming at the end. I know it's kind of tough, and I know everybody's got a lot of stuff going on, but make sure you do try to schedule some of your stuff earlier than later. But I hope that what we did today here, y'all, was helpful. Did any of this make sense? Did we do good with what we did this afternoon? Are we good in the hood? Anybody? Everybody so quiet? Yeah? Okay, just making sure, y'all. Okay, it helps some? Good. Yes, you can. You guys can. Okay, good. So Ruth, don't worry. I recorded everything. I am going to send the video out for you all today. So yes, definitely. You all got questions, guys? Let me know. I sent out a video, I think yesterday. I sent out another 2 today. Any questions you guys have, guys, let me know. And then when I send them out, even if you didn't ask me the question, check it out, because there's probably a question that I've answered that you still might have, and you just haven't got